So today in this video we're gonna talk about the device which helps to the measurement of pressure, or which is used to measure the pressure, that is known as manometer. So that is used to measure ideal gas. So when it is an ideal gas, we can use this to measure the pressure. So it consists of two types of manometer. One is a closed end manometer and the other one is open end manometer. So that closed end manometer, that is used to measure under atmospheric pressure. So when the setup is under atmospheric pressure, it is used to measure that one. So that is closed end. Or what is open end? So it is used to measure under or above atmospheric pressure. So if the gas has the pressure under or above, then we use the open-ended manometer. So now let's look at the closed-end manometer. So this is our manometer setup. Now let's say here we have some gas, and before the gas, let's say that here we have the mercury filled inside the gas. Okay, so first of all let's consider there is a gas. Okay, so there is a gas and gas is trapped inside it. Okay, and here till the gas is there. Okay, and here also we consider there is a gas, and here till there is a gas. Now if we look at this, now here the mercury start filling, so we have a mercury trapped over here. So here mercury is trapped inside and it is filled till this level. So what actually we have this type of setup, and in this type of setup we have a gas trapped over here. So here if we say it is a gas, okay, and what is here it is a vacuum. It must be vacuum here. If any gas is trapped here, it will be considered under the, when we want to calculate the pressure of the gas. So let's say the height difference of this mercury level, let's say it is H. Okay, and it is mercury in liquid state, and the gas is here. So if it is our ideal gas, so it must be having some pressure because it is having moles. So we could use the PV equals to nRT over here. Now generally it is used to measure the pressure of ideal gas. So in real life we know there is not an ideal gas, so there might be some consideration also, but it is used to measure the pressure of ideal gas. Now if we talk about like height of the column, as we have seen previously in barometer, that if there is a height of H, then the pressure due to this height will be equals to mgh. Now let's consider 2 points. This point is A and this point, let's say it is B. Now let's see what could be the pressure, okay, at A and pressure at B. So we know pressure at A will be equals to pressure at B, and let's say from this knob we have just filled a lot of gas. Now this gas will keep on expanding, and some time it will going to end over here. So when it going to end over here, it must have some pressure difference because it is vacuum and here it is gas. So this gas will try to push that mercury column and it will keep on rising till the pressure becomes equal. So pressure at these both points becomes equal. Now pressure at A, due to what the pressure A is, what the gas, what the pressure that is being exerted at the point A. So that pressure is due to the pressure of the gas. So PA, the pressure at A is equals to pressure of the gas. And if we talk about the PB, what is PB pressure at B? This is due to height this column. So height of this column pressure is mg, not mgh, it is rho gh. Rho means our density of the mercury. So this is rho g into h. We have seen obviously the pressure due to a column of height h is rho gh. So now here, what is the pressure of the gas if there is a gas filled inside it? Okay, so pressure of the gas is equals to rho gh. Now as we know, in case of mercury, 1 atmosphere pressure, that is equals to 76 centimeter of mercury in liquid. Okay, so when we talk about our general temperature, obviously mercury has a very high boiling point. So at a normal pressure, there will be a very negligible amount of mercury in vapor form. So 1 atmosphere equals to 76 centimeter of mercury. And that example, if we have the height, now let's say example, if we have this height equals to 15.2 centimeter of mercury, in that case the pressure of the gas will be equals to 15.2 divided by 76, that is equals to 0.2 atmosphere. If we want to calculate the pressure in atmosphere, or we could also calculate the pressure in torr, and the pressure in torr equals to, like here 15.2 centimeter means 152 millimeter. So here the pressure will be 152 torr. So here this is also, we can measure the pressure of the gas, and we can also convert it into like atmosphere, or we can also convert into Pascal, which is Newton per meter square. So that's how we use that closed end manometer to measure the pressure of a gas. Now let's talk about the open end manometer. So in open end manometer, let's say there is again a gas trapped inside it, that is being inserted in that particular chamber, and this chamber we have like this gas. Okay, so now let's say that now it is open ended, means this end is open. Okay, so here it will be having the pressure of atmosphere also. So now let's see the first case where the mercury level here and mercury level here. Okay, so what is there? The mercury is filled inside the, again, this tube, and what is the height is, again let's say the height is h. The height that here is h. So if we want to see like what is the pressure here also, the pressure at point A and point B must be same. Now if we talk about the pressure and pressure, so what is the pressure A? We know pressure A will be equals to pressure B, and pressure A equals to pressure due to gas only, because here we have only gas. And what is pressure B? Pressure at B equals to that, here we have also pressure atmosphere. So pressure atmosphere is here. As we go till the depth of h, it will be pressure atm plus a rho g multiplied by h. Okay, so that is due to height, pressure due to height. So pressure of gas is equals to pressure of atmosphere and pressure of due to column of height h. So it comes out to be pressure of atmosphere plus rho multiplied by gravity multiplied by height h. Now let's consider another case, like in the same manometer. If let's say this is the height and another height is this, okay, and here the height is h. So here how will we make the calculation? We know that in that case, when the height of that gas column is more as compared to this, so what will be the equation? Again, if we had to consider these two columns. Okay, now again let's say it is C and it is D. So in that case, pressure at C will be equals to pressure at D. And what is pressure at C? Pressure at C equals to pressure of atmosphere. And what is pressure D? Pressure at a point D will be equals to the pressure of gas plus pressure of height pH. So here a P gas plus H will be equals to pressure in atmosphere, means pressure H due to column height H, and here as we see the pressure of gas comes out to be pressure in atmosphere minus pressure of column of height H. Now let's see the third case if both the pressure are same, here also. So let's see a point E and F when the mercury is filled like this between the point E and F. So in that case PE equals to PF. So in that case the PE, the pressure at point E is pressure due to atmosphere and pressure due to F is pressure due to gas. So again we have to see when two liquids are at the same level. Okay, if we have a very ununiform structure like this is our structure, okay, and we have again a tube like this, and we have again a container which is like this, and again we have a container which is like this. So in all these container, if we have some liquid filled till the same level, okay, if the level of all the liquid is till the height of H, so no matter what the how the liquid is, it must be obviously continuous. Okay, so the pressure at bottom due to that particular height of that liquid will be in all the case A, B, C, D. If you see all the points bottom at the bottom of that vessel or container, so PA will be equals to PB, that will be equals to the pressure at C point, that will be equals to the pressure at D points, and that will be equals to rho density multiplied by gravity multiplied by height H. So that is all the pressure at the point we have. So that's how we use this manometer to measure the ideal gas pressure.